We're going to spend some time asking very practical questions on chaos engineering. We just saw from the previous talk that there's a lot of evolvement in chaos engineering, where we heard from Netflix 10 years ago to developers asking, we need to do a golden test versus silver testing, right, of chaos testing. So I'm going to ask a couple of basic questions on how chaos engineering has evolved. He's a practitioner. I'm basically a vendor or a writer of chaos engineering. So let's hear it from Mahesh, who's a VP of QA at Accenture. Mahesh, you've been doing quality engineering for quite a while now. Chaos is not new to you, but you've seen this evolve over a period of time. Can you talk about how chaos that was introduced 10 years ago to now, how do you see it coming along?
So I see chaos engineering. There are a couple of things that I wanted to talk about. One is the current notions around, the mental model around chaos engineering or chaos testing, and how it has evolved in practice since the time it was introduced by Netflix more than a decade ago. When they started it, when Netflix started chaos engineering, it was more of a production, something like a monkeying around in production. They had Chaos Monkey and lots of tools to bring down microservices. And so that the design and architecture keeps evolving to be very resilient, right? But the way I see it now with increased cloud adoption is chaos engineering in its scope and practice and tooling has evolved considerably. I'll tell you what is the current state and what it ought to be. Currently, chaos engineering is basically an experiment-oriented improvement, wherein you design thoughtful experiments to discover the behavior of a complex distributed system and continuously improve. I leave it at that for now. So the earlier model was bring down stuff and see how it works. It's like tying my leg and then asking me to run and then saying, am I able to run fast? Now it is more thoughtful. The inputs to the experiments are more, I would say, structured. And we use observability tools to observe behavior, experiment, evaluate, learn, and improve model. That's the evolution that I would summarize in the last 1 year that from Accenture perspective.
Great. No, that's good to see. Just to summarize, earlier chaos testing is more of a specialized form of testing to break things while a critical service is running, to now where you're using chaos engineering as more of a use case to validate the architecture of your bigger service, right? Can you walk us through a couple of examples of, in your experience, how chaos engineering has helped revealing a problem in the architecture?
Yeah, so I think you mentioned the right thing. We've been talking a lot about process and software delivery process and platforms. Primarily, in a software delivery platform, a software delivery platform is basically a value delivery platform, right? It ensures a smooth flow of value from idea all the way up to customer. Now, we talk a lot about process quality, which is the ability of a process to continuously provide feedback, and process quality ensures agility, right? And then we talk a lot about functional quality, which is functional feature richness and feature correctness. What is not often spoken about and which is very important is the structural quality. There are 3 dimensions to quality. Process quality, we understand. There are metrics to measure process performance. Functional quality, functional correctness, and feature correct, which is binary, by the way, right? Third is, which is, I would say, as community, we need to focus more on the structural quality, which is the architecture quality. Now, architecture quality, if I just use a term, it's a very nebulous term. What does it mean? In the input side, architecture quality is all about decisions. Architecture is not just diagrams, decisions. Architects have to make tough calls. I don't know how many of you read the book, The Architecture Hard Part by Neil, I think, right? So the architecture quality is all about making decisions under uncertainty because cloud is distributed. Trade-offs, there are trade-offs, mutually conflicting goals, the attributes like performance, security, performance, throughput, latency, they're all mutually conflicting always, right? So when these decisions are made, how do you evaluate the runtime consequences of these decisions? So on the input side, we have to ensure that the chaos experimentation is thoughtful. On the output side, the output of chaos experimentation and engineering basically it enhances value unlock from cloud, application value unlock from cloud, and aligning to the business goals. Second is reducing the risk of distributed failures. And third is application resource optimization. Applications today can harness resources quickly on the fly, programmatically. So cost optimization at a runtime, right? So the examples here are, if you look at value, there are two examples that I'll outline. Sorry for being a long answer. I'm sorry, I thought I have to give this. Chaos engineering or chaos testing being a larger scope rather than just a mere. One is, we were asked to improve the daily trading volume of a trading platform from 100 million to 120 million. So chaos engineering helped us to improve the throughput. Easier said than done, but the experimentation involved continuous optimization of the architecture to improve value. That is a value. Second is, for a bank, we found that, during a Zookeeper upgrade, there were multiple duplicate transactions processed, leading to double debit and double credit, right, during chaos experimentation. So value was improve the business throughput, right, of trading volumes per day. Risk is primarily all these kind of distributed failure risk. Functionally, everything was okay, right? Third is obviously, we are continuously asked to improve the cost efficiency, runtime cost efficiency, not the configuration cost, the runtime cost efficiency of the application. The examples here are value examples wherein we improved the business throughput, where we discovered very, very, I would say, high critical failure mode. And third is the cost optimization.
That's great. That was pretty interesting to see that you use chaos engineering to improve the value of money going from 100 to 120. Yeah. You also run a large services delivery organization. We have seen chaos engineering is by far a special discipline where you need a very special technical skill team. So in your experience, what are the general skills that are required to deliver chaos engineering in a large services organization, and how do you go about skilling them up?
Yeah, I think there are a couple of composite skills in chaos engineering. I think it's chaos engineering has to have, the team has to have composite skills. One is obviously the curiosity and ability to look for failure modes, right? We do failure mode analysis before we go into starting to use harness chaos engineering tools. So the input to the chaos engineering is failure mode analysis. So we do a component interaction analysis of the architecture. We statically discover the failure hypothesis. We build a failure hypothesis using a table. It's much beyond the hypothesis that today they talk about. So we need architecture skills. We need some kind of a skill to a curiosity and skill to identify how something could fail, not just how something works, right? And third is a high degree of tool appreciation and understanding. So architecture knowledge, a quality orientation and testing knowledge, and third is the tooling knowledge. And fourth is definitely a chaos engineer has to have a good understanding of the value stream or the software delivery platform, because it is important to integrate this into the software delivery pipeline. So all the three skills, and the fourth is more of the appreciation skills.
That's interesting. I mean, like, just for the audience here, we talked about tooling, and it's been quite a journey for chaos engineering to come from only for SRE with special tooling to somewhat, we have seen an example of Alex doing the demo this morning where at a click of a button, you can actually inject chaos into the pipelines, right? So chaos tooling is very important, and then thanks to a lot of innovation in the last few years, chaos has become so easy to inject and observe. So that brings down to one more question. What are the prerequisites for someone to start chaos engineering in any organization, right? So we establish the benefits of chaos engineering, but there seems to be a bit of inertia in larger organizations that, like, do I have everything to start chaos engineering? So in your opinion, what are your recommendations? When do you think that you're ready to start chaos engineering practice?
I think from an importance and criticality perspective, it's important for every organization to adopt chaos engineering. My first recommendation is to understand the concept. The term chaos engineering, personally, I think it does not really reflect the importance because chaos testing is too narrow in its scope. It just kind of removes, bring down microservice, bring down some servers and see how it behaves, right? I think we go to first to the culture of experiment-driven architecture improvements and the culture of recognizing that architecture decisions drive architecture decisions are very critical for an organization adopting cloud to realize business success. So when we connect the architecture quality and architecture decisions to business success, right? The business success of value, risk, and cost. And for example, I said as an algorithmic trading needs a very real-time response, but an e-commerce may not need a real-time response. An energy company will have a different attributes, fit-for-purpose attributes, right? So one is to kind of associate chaos engineering, a culture of, I would say, change the name of chaos engineering to empirical architecture optimization or continuous architecture optimization rather than continuous chaos, right? One is a culture, understanding that chaos engineering is a very critical part of continuously improving structural quality, start to talk about structural quality in software delivery conversations, right? And second is to get the right tool. Connect the culture and the tool through training. And I think it's important for many organizations to have, while it is important for developers to be able to perform self-service, means we talked about experience, developer experience, it's important to have a chaos engineering experts, consultants, who will guide the developers themselves to conduct their own chaos experiment. And third is obviously something like a chaos experiment kitchen, like a chaos kitchen, right? You have those ingredients to put together, and then boom, you have a recipe for discovering problems. So more than testing, it's discovery of issues, discovery of opportunities to improve architecture. I think that culture of continuous architecture optimization we should include in our conversation. So when we start including, the CXOs start understanding how architecture decisions, quality is directly linked to business success. Then we start to build the right skills. We start to get the right tools. We know what the right tool is. And then we start to slowly evolve chaos engineering practice.
Yeah, I mean, harness chaos engineering definitely is the right tool to start off with, right? You talked about chaos kitchen. In technical terms, we call it as a chaos hub at Harness, right? Chaos hub comes with a bunch of experiments that you can actually start off very easily, right? I mean, introduction of culture of chaos is by far a bit of a bottleneck in the adoption of chaos engineering. And what I've seen from my observation in the last 5-6 years is there's a little bit of who should use chaos engineering. That's a question, right? So primarily it's been taught over the years that chaos engineering is usually a practice of service reliability engineers or SREs. But we have seen now that developers are starting to think of let me use chaos engineering as a way to understand my product architecture better, right? And we talked about developer experience, developer productivity all over the day today. So this leads to my next question. In your opinion, do you recommend chaos as starting and going left shifting or starting and going right shifting? Where do you start? What are the recommendations generally, from your experience?
Yeah. So everybody seems to be shifting left, right, and shifting right. I think I would say, let's transcend that question of shifting left and right. To me, chaos engineering is a continuum. Let me explain what I mean by that. I don't know. I don't have enough words to explain what I have in my mental model. So, for example, in a software delivery, in a value stream, you have leading indicators and lagging indicators, right? When you take the flow of value from idea all the way up to customer, you want to lead the value, you want to guide the value. You don't want quality gates. That's the old system. Today, we have quality gates. Something breaks, we stop. How do you ensure that there are no quality gates, but quality signpost, quality guidance, right? So if you want that, then we got to have a continuous analysis of leading indicators, predict the lagging indicators, right? So for me, shifting left and right is a continuum. When you start to do the stories, you look for ambiguities and say, look, this story seems to be a bit ambiguous. There could be an impact on resilience or impact on throughput. Let me flag this and then include that in the failure mode analysis. And then take it to the code quality. The output of code quality tools today is a huge bunch of findings. Nobody looks at it because there are too many false positives. So, but then if you look at outliers and flag them, all the leading indicators, which is your story analysis, the failure mode initial static analysis, and the code quality, and all the leading indicators should go into the chaos experiment input. What stimulus, what simulation are you going to give, right? That's the shift left, if you will, right? You kind of start, left for you, left, right? Chaos engineering is this. And then you have the output. You use observability tools. You take production incident logs and trace and metrics, and then also use them as inputs to the shift right. So we have feed forward. I'd rather use the word feed forward and feed back. Feed forward to have taking a leading position. It's like a pilot, right? There is no shift left for a pilot or shift back. There's a constant feed forward. There is bad weather ahead, so it's a call. There are false positives, but then the pilot makes the best call. So to me, chaos engineering is a continuous process wherein we analyze leading indicators, use them, take a position on the lagging indicator, which is the throughput, response time, latency, resiliency, security also, then the cost efficiency, conduct experiments, learn, evaluate, improve, and again redo. It's like a continuous chaos. But I don't know whether chaos is the right word. It's empirical, experiment-driven improvements. It's a very important part of software delivery, if you ask.
It's called more of a continuous resilience now, continuous chaos.
I think we have more attributes than resilience here. We have throughput, response time, all performance, then cost efficiencies, latencies, all that should be included in the chaos, not just resiliency.
Yeah, definitely chaos engineering has been made easy. Recently, Harness has released a chaos maturity model where we break it into 4 parts. You start chaos with 1 or 2 experiments, wherever you can, to start automating, scale, and then go to the mature expert level where chaos experiments are randomly injected or automated, where you're always expecting some chaos is happening in your services, and then your services continue to run. Before we let this discussion finish, where do you see chaos engineering practice in terms of adoption going in the next few years? Is it going to be still a little bit of a push mode, or is it going to be a pull mode where people
I think,
see it?
I think as practitioners and tool developers and technologists, we have to evangelize, or we have to broad base and convince the CXOs of the importance of architecture quality, and not limited to only resilience, but all the quality attributes, because an application functionality, if two different applications, competitors, the functionality, if they are same, they'll be same. But what differentiates them are these attributes, throughput, performance, latency, response time, error rate, resiliency, availability, reliability, security, and cost efficiency. These are the real differentiating attributes, the fit-for-purpose attributes. So to me, chaos engineering ensures differentiation in the product. So we talk about process to product mindset. The product differentiation comes from structural quality apart from the process and functional quality. Let's leave this conversation thinking that there are three dimensions of quality: process quality, functional quality. Both are taken care very well. I think great thing to have structural quality introduced in the form of chaos experimentation.
So the summary is use chaos engineering to improve the structural quality
Yes.
of the product and services.
Yes.
Well, that's a great message for us. Thank you very much, Mahesh.
Thank you, Uma. Thank you for the opportunity. And we enjoyed it.
All right.